Hello. Okay. Hi, I'm Martin Cayley, and I'm the VP for Dremio. I had put a presentation together today, but I've spoke to Andy, who is one of our customers, and I thought it'd be much better for him to explain the processes and procedures he went through to decide on how to choose a product and a tool for doing much faster analytics on top of a data lake. So I'd like to introduce Andy Kenner, who's going to talk about his unexpected journey through getting faster analytics on data lake technologies. Thank you.
Thanks, Martin. So as Martin said, I'm going to talk to you about our experience with Dremio. First things first, my name is Andy Kenna. I'm head of data with a company called Renaissance Reinsurance, or RenRe as it's known in the market. I've been there for 14 years, and the past 18 months has been spent locked in a room avoiding people, so this is all types of weird. In fairness, though, I think the organisers knew that, because I think right now it's probably easier to get a beer than it is to get a water. So I invite you to connect to my LinkedIn profile down here. If there's any questions you have around Dremio or experience, the tools, technologies, if there's anything you don't understand because of my Irish accent, do reach out, connect, message. And when you click on the link, you'll be brought to a profile with this picture. That is me, clearly a pre-pandemic photo. Trust, safe enough. So RenRe is one of the largest property and casualty standalone reinsurers in the world. It was formed over 28 years ago after Hurricane Andrew smashed into Florida and Louisiana. Really, the purpose of this slide is just to draw you to some of the magnitude of the numbers that we are dealing with. So we're talking about $20 billion assets under management and almost $6 billion gross written premium. So as you can imagine, they're big numbers. It's an awful lot of big data under that. In the past 7 years, we've gone through a tremendous amount of growth through 2 acquisitions. We acquired a lot of data, we acquired a lot of systems, and so recently we decided to just reevaluate our data strategy and what our data vision was. So we chatted to a bunch of people across the organization, and really what it boiled down to is people wanted simplified access to trusted data. So that's 5 words, sounds very simple. Sure, we all know it's really not that easy. But what people wanted, they wanted faster access to data, so they wanted reports to be quicker. They wanted different ways of accessing the data, so not us prescribing, you're only going to get this data through a report and this data through a cube. They also then didn't want to go to a report and get one metric and go to a cube and get another metric, so they wanted to trust the data that was available to them. So we started thinking about, what's the single source of truth for our data? We wanted to strategically then democratize data. I'm hearing a lot over the conference around this data literacy. We wanted to put data in the hands of the everyday user, so not your power user. We really wanted to put data out there and make it available for everybody. On top of that, moving into different jurisdictions around the globe, we had more and more regulations. There was more requirements to be locking down our data, to be governing our data more than what we were doing. Being across multiple different clouds didn't make this process easy. Spinning up data sets around the company in different areas made this very complex. So last year we decided to do a data virtualization product evaluation, or POC, to refer to it internally. And the way I describe data virtualization is it's like a logical layer that sits across your data and enables you to query into your data sets. This sounded really good for us because it simplified the process. It's a semantic layer across your data set. So we've got data, tons of data on SQL Server on premise. We've got data up in Azure Data Lake, almost 100 terabytes of data up on Amazon Redshift, and we're moving more and more data onto S3 as well. So the criteria for this product evaluation really involved connecting data from different sources together. So we have our financial data, or actuals as we call it internally, and our expected data, or our models data, which is all held up on Redshift. So we have a nicely named system, actual versus expected internally. We wanted to see how can we simplify this with data virtualization technology. So right now, the expected system takes in all of the actual data on a nightly basis. There's ETL queries over that, or there's ETL that's applied to that through different queries, Windows functions, and then an aggregated data set is dumped out to SQL Server for analysis. So lots of things wrong with that process. There's copies of the data, there's data is not refreshed quick enough, it doesn't perform, there's lots of issues, so we really wanted to see how we could simplify that process. Another thing we wanted to do was combine cube data. I actually don't know why I've got tabular mode in brackets there, that's unnecessary, but we wanted to combine SSAS cube data with relational data as well, because we do have a lot of analytics. It's quite easy to build in cubes, not so easy to build in relational databases, so we wanted to query them two data sources together. And finally, with more and more data moving to S3, we wanted to see how can we improve that, how can we query over that, what tools are available there to help us. Spoiler alert, we went with Dremio, but we did do an extensive product evaluation. We looked at tons of tools in the market, we created a short list, we did proof of concept with these vendors, and have chosen to go with the technical term clunky to describe the vendors that we evaluated. We found they were difficult to install, difficult to get up and running. Like everything we were doing was in the cloud. These were platforms we felt that were built for on-premise and imported to the cloud. There's a bunch of issues with that. We just, quite frankly, we didn't have confidence that if we did decide to go with the product that we'd be able to get it running in the way it was in the POC environment in production. During the POC with the different vendors, just the support, we found them just wasn't great. And on top of that then, performance for the use cases we had just wasn't acceptable. We'd set a high bar because we knew the way we'd architected some of the systems, there was ways we could improve that internally. So we set a high bar with our performance and they didn't meet that. On top of that, querying files on the data lake, this was not the strength, the performance is not worth noting here. So while not a data virtualization player in the market just alone, we stumbled across Dremio and we found that they could do a lot of what we were looking for and potentially some other stuff. So we reached out to them. I actually remember the first call we had with Dremio, because right at the start when we were just some small talk, they were quite honest about what they could do and couldn't do. And that was just refreshing after dealing with some of the other vendors that we had. So that was great, just got off to a really good start. They also challenged our use cases, particularly the SSAS cube and relational data use case, or SSAS cube and tabular mode, in case you've forgotten. They challenged that use case for us. They said, they really dug into why we were doing that. The reason why we were doing that was because of constraints within the system. Like we couldn't do these type of queries we could do really easily in cubes. We couldn't do them with relational data. So they challenged that use case and we accepted it. We decided, let's tweak that use case and let's just do the calculations on top of the relational data. So got off to a really good start and it continued like that. The support during the whole process was great. The platform itself was easy to install, like it was built for the cloud, so it was spun up really easy, and within a short period of time we were querying into our different data sets and getting results back. And the results we got were just super fast. Like where we had our bar, Dremio were well over that. So I'll run through some of the results. These slides need a bit of explaining because they were presented internally about a year ago, but we had one query that was running on Redshift. This was a complex query across quite a large data set that basically did a lot of aggregations, there's a lot of functions applied there. And on Redshift, it took 480 seconds to run. On Dremio, using a direct query, it took a little bit longer to run because of the version of Dremio we were using at the time. Had to do some of the aggregations within Dremio. But it is worth noting at this point, this is on a 2-node cluster compared to a big heavy-hitting production Redshift cluster that we had. We then decided to take the data onto S3, so we used the Dremio ctask function. We selected star from all of the tables, dumped it into Parquet and S3, and had the look and feel of a database. But it was just far better in terms of performance. So you took the query came down to 44 seconds. We then, so this was us doing this as well, by the way. This wasn't Dremio experts coming in optimizing things for us. This was myself and my colleague who then did some basic optimizations or reflections on Dremio, and we got it down to 7 seconds, which compared to the original query, this is amazing. But right now we're looking at this, so we looked at this slide on Tuesday, and someone on bar is thinking, like, why did we settle for 7 seconds? We're confident now in a production environment that's coming down sub-second. With some more intelligent reflections, it's getting much quicker. Admittedly, the SQL Server use case that we had where we were querying in, this slide is just a bit all over the place. The query that we had was trying to return an awful lot of data in SQL Server, but was also doing a lot of calculations on that data. So in the environments we were running on, we were just blowing up TempDB. So after 12 minutes, TempDB would fall over, query would stop. So we didn't have a baseline. I did get the query running in a production environment out of hours, and it took 70 minutes to return. So this was just far too slow. We put Dremio on top of it using S3, using that CTAS function, bring it out into Parquet again, and we got the query down to 33 seconds. With reflections down to 3 seconds, and again, we're confident we could get that faster now as well. So really shocking performance we got from Dremio, just super impressive. We were all blown away at this stage. So that was our, the first slide was our expected. This was our actual, so we were able to join the two data sets together really quickly. It showed us there's a far simpler architecture there for us. This was then, we were able to do our SSAS cube and relational data, we were able to do them queries. This was data on S3, but we were able to put it on top of other data sets we had in S3. So it's meeting all of our criteria at this stage. So we're really happy at this stage. It was around then that my impeccably tanned colleague, Martin from Dremio, who introduced me, he shared this blog post on Project Nessie, which was source control for the data lake. I read the blog post and had to read it a few times because it took a while to get my head around it. I remember at this time sharing it with my CTO, and he was very impressed by it, and he actually used the term thought leaders. And that is just not a term I've used before. It's just not, obviously the words are in my vocabulary, but together I've never referred to a company as thought leaders. That's how we refer to Dremio internally now. Whenever we're doing presentations, we talk about their thought leadership, we talk about the blog posts, what they're bringing to the market. So at this stage we're in, we decided on the spot practically, we're going to license this. We got the super fast results, we got these thought leaders, let's go. So we licensed Dremio, and this is a very high level view of what our architecture looks like, where we've got our data source on the bottom, you've got this semantic layer with the query acceleration functionality within Dremio. But then on top of that semantic layer, you can access that data through a variety of ways. You can come in through R, through Python, SQL, Tableau, Power BI, all technologies we use come in to access that single source of the truth. So we're able to, we actually brought our actual data set out that's governed, it's scrubbed. On top of that, it's documented. We have, we've got metadata, we've got lineage, we've got a wiki on how to use the queries, how to use the data. So it's really powerful. We went for a data mesh approach with our data lake. So instead of having one big data lake, we've got like a bunch of small data ponds, as I've heard somebody refer to them as, with Dremio being the fabric that's bringing them all together. And also what we got after we licensed them was it gave us an alternative way of architecting our applications. So I'm going to touch on two use cases that just shows some of the different ways we've used Dremio to solve problems. So it's quite a busy slide. Basically, we have a mortgage data use case where we get 600 gigabytes of data from an external vendor. It's all modeled data. We use a very legacy Microsoft BI stack approach for solving this problem right now, where we've got SSAS is connecting to SFTP, it's downloading the files are transformed into a staging area. The staging area is then aggregated, that aggregated data goes to a production database, and then we have a Tableau data extract sitting on top of that for query performance. There's so many things wrong with this approach. Like, it's such a big data solution. We've sort of crammed it into SQL Server. It's not really fit for purpose. The DBA team hate the solution. It's just an absolute headache for them. The business team aren't overly happy because all they have is access to aggregated data. They can't get the full history, can't get to the granularity of the data that they have, so they're not overly pleased. So we decided to look at how can Dremio help with this. So we did some spikes, we did some experimenting with Dremio, and we worked with Defender, and we were able to bring the data set from 600 gigs down to 150 gigs just by asking them, can you give us the data in Parquet? So they gave us the files in Parquet. We put them onto S3, we put them into our nicely partitioned structure we had in our S3 bucket, put Dremio on top of it, refresh Dremio, then Tableau can access Dremio. So it's just a far simpler solution. The current, or the old solution, I should probably say, takes 24 to 36 hours on a good day, on a good month, to get very limited insights into that data. So they can't get access to the full history, can't get access to the full granularity, and if anything goes wrong, it takes a considerable amount of time to debug where that is, because we're copying data as we go along, we're aggregating it, and if somebody asks us, why is this number this in the report, we're tracing back through the stages. Dremio, far simpler, down to an hour. Again, confident we can get that down under an hour as well. So it's far quicker. It's at least 24 times quicker. But the Tableau interface to Dremio can access all of the history. It can access a finer grain of data. So it's just far better for the team. Sort of touch on some of the results, some of the benefits there. It's no longer a DBA headache. We've got quicker times to insights. There's a bunch of benefits there, but the biggest benefit from this project came to us as a bit of a surprise. So we exposed the mortgage model data through Dremio. We'd already done the work where we plumbed in our actual data, so we have this expected data set. So now we can do actual versus expected on our mortgage book. And it's actually hard to explain, because that was not in scope for what we were trying to do. In fact, it was so far out of scope what we were trying to do, because the business team just didn't think it was possible. They're so anchored in the limitations of the technology stack that we currently use that they never thought about we could do this. But now they can do it, and they can do it for free. So it's not like a massive development effort. They get this for free out of the box with our Dremio architecture at the moment. Another use case we have is a bit of a computational use case. So we didn't think we were going to be using Dremio as a computation engine. But what this is, it's quite a simple computational problem to solve, in that it boils down to, it's a many-to-many join across non-distributed data. So the difficulty with this is that because the data is not evenly distributed, certain technologies just struggle with it. So we thought we'd test out Dremio. And we had a bit of a bake-off between different technologies like Dask, Spark. We ran this on Redshift. We've got a ton of data backing up this. But basically what we had was 3.8 billion rows, and then 11,000 rows, many-to-many join, aggregation on top of that, blowing the data up to over 60 billion rows. So this is a subset of the results that we have, and basically what this is showing, that we started off with 16 nodes. When we doubled the nodes, the queries got even quicker. When we doubled the nodes again, they reduced by 50%. In my experience, things don't scale like this. So we were very impressed with Dremio's scalability. But this is just a fraction of what we tested. So this is with a high cache. We checked it out with a high CPU. We tweaked the thread counts. We tweaked all types of things to the point where we are now, where we have this query just absolutely flying. And to put it into perspective, historically, this would have been a large part of what we would have called our nightly process, where we're down to talking in minutes now. Really, for me, the beauty of this is just in its simplicity. It's 16 lines of SQL that we can give to Dremio. It's a low barrier to entry. Dremio can spin up the instances, can tear them down, can look after it, and it's just fast. It's fast and it's simple. So we were really impressed at this stage. And in fact, from our results, we now believe that where your problem can be expressed simply in SQL, because you can hack all types of things around in SQL, where it can be expressed simply in SQL, Dremio will not be beaten. So I'm going to take you through a couple of slides that Dremio presented us back when we were chatting with them last year. And he talked about avoiding the massive engineering project. So this is quite similar to our architecture or tech stack at the moment. But what Dremio talk about is that they can simplify this, so you do not need many of the items in this diagram, like cubes, like your maybe SQL Server caches, your data extracts in reporting tools, which for us, we just ban them now that we have Dremio. We don't need to do that. Until you get down to something like this, just nice and simple, Dremio on top of Redshift and S3, that gives an awful lot of power, an awful lot of functionality. Where we are now, is looking at how much of Redshift do we need? Like, I think if Dremio presented this slide to me last year and we were looking at them, we probably wouldn't be here right now because it's just too far-fetched. But these are the conversations we're having internally at the moment. How much of Redshift do we need? Given we have S3, or we can use S3, we can use Dremio. It looks like a database, feels like a database. For certain analytics, do we really need Redshift? The answer is no. So yes, just to summarize, I wanted to put up a few quotes from some of our engineers just to try and convey the enthusiasm and excitement that Dremio has caused in Renri. And some of the benefits since we've licensed the tool, like some of them we've talked about, but it's faster time to value. And if I think of the mortgage use case, that's an understatement because there should be faster time to better value. We're able to get a solution running far quicker with insights that weren't even thought possible using very simple architecture. So like, we're really blown away by that. It's given us this enterprise-wide semantic layer, facilitating us to have a data mesh architecture underneath on the lake. And on top of that, we have happy engineers. Like it says productive up there. Happy and productive don't always go hand in hand, but we've got happy engineers working with this technology. We have people wanting to move squads internally to come and work with Dremio. So we started out in this journey on a data virtualization POC with a bunch of success criteria. We were thinking we may need to compromise on some of the criteria, as we often have done in the past with these proof of concepts. We stumbled across Dremio. We had to play around with it. We licensed it. And in the end result, we compromised on none of our success criteria. Dremio really blew us away with that. It's given us a new way of architecting applications. It's forced us to think about how much of Redshift, how much of other technology stacks do we actually need to be using. It's massively accelerated our move to the data lake. But on top of that as well, it's just been a paradigm shift internally in thinking about how we solve business problems, how we approach data engineering projects. We're thinking about things in a way we've never thought about them. Likewise, our business people are thinking about uses of data that they've been anchored to not think about. And for me, so much of that was unexpected, hence the unexpected journey. Thank you.
Thanks to Andy for that. If you want to discuss this in a bit more detail, Dremio's the stand with the massive screen, and you'll see Dremio in big letters on the back of that. We're serving beers at the moment. We give out free Ray-Bans while we talk to you. So please come down and discuss your challenges with us later. Thank you.